Good morning, everyone. Today we're going to go over some momentum and impulse problems. This video is mostly inspired by the questions that I got from people about the introductory momentum worksheet. And most of the answers are usually due to a couple little things. So let's begin. First thing is remember your units. Things won't work out if they're not in meters, kilograms, and seconds because all of our units are based off of the meter, the kilogram, and the second. So let's look at this example and see what's going on. Determine the momentum of a 770 kilogram car driving down the highway at 95 kilometers per hour. If you're thinking, oh, I'll just do my momentum is equal to my mass times velocity, and you choose to just plug it in as such, 770 kilograms multiplied by 95 kilometers per hour, that's going to be wrong because we need to convert those kilometers per hour into meters per second. Remember, the conversion to turn your kilometers per hour into meters per second is to divide by 3.6. And that was 26.4 meters per second. So that means our proper answer here is actually going to be 770 times 26.4. 20,300, although it looks like there's only two sig figs, so 2.0 times 10 to the 5 is actually a better way. And that's kilogram meters per second. Sometimes in our problems, we're also going to have to use kinematics or forces before we can actually begin doing the problem. Let's take a look at this one. A 5 kilogram box is dropped off of a bridge. Determine how much momentum the box has after it has fallen 30 meters. Well, if I wanted to find my momentum is my mass multiplied by my velocity. But the issue here is that I might have my mass, but I don't know my velocity. How fast is it going? Well, we can go ahead and do this using some kinematics. So if I was thinking in terms of kinematics, I would say, well, let's write out my VI, VF, ADT. Since the box was dropped, the initial velocity is 0 meters per second. The acceleration is going to be 9.8 meters per second squared because it is falling. And the displacement, we were told, is 30. So I'd be able to use the formula that uses VI, VF, A, and D. In other words, VF squared is equal to VI squared plus 2 times A times D. Or VF is going to equal the square root of 0 squared plus 2 times 9.8 times 30. Which turns out to be 24.2 meters per second. Now that I have my final velocity using kinematics, I can find my momentum by taking my mass, multiplying by my velocity, which we see is 121.2 kilogram meters per second. So sometimes we see that we have to use a little bit of kinematics or a little bit of forces before we can find things using momentum. And that's perfectly fine. All of physics builds off itself. We should never forget the things that we did earlier in our semester. Let's do another one that's going to require a little bit of forces work. Jerry is pushing a 45 kilogram crate with 300 newtons of force. There's a coefficient of friction of 0.44 between the crate and the floor. Determine the impulse of the crate after 5 seconds. Well, I remember impulse is my change in momentum, and I can get this either through mass times the change in velocity, or, as we discovered in some of our notes, that it is the force multiplied by the time. So all I need to do is determine the force. Now the thing is, this is not any old force. This is going to be the net force. I'm going to need to find the net force of this situation. So let's make ourselves a box and see what we've got. We have the force of Jerry here, which is 300 newtons. And there's a force of friction that's resisting it. But we don't know the size of this force of friction yet. That means we're going to have to use our other forces that we're aware of. There's some gravity and and some normal force. Now we see gravity and normal force are balancing. So if I were to determine my gravity using 45 times 9.8, that will help balance my normal force. And we'd be able to use this to calculate the force of friction because it's the coefficient of friction multiplied by the normal force. So that would be 0.44 multiplied by 441, which turns out to be 194 newtons. So the net force in this scenario is going to be Jerry's force, and working against Jerry's force is the friction, so we subtract it. So the net force is 300 minus 194, leaving us with a grand total of 106 newtons. This is what we're going to put into that formula right there. So our impulse is going to be our 106 newtons multiplied by the 5 seconds. Our final impulse is going to be 530 Newton seconds. Now remember, the units you could also use are kilogram meters per second. It's the same thing. We're going to go over one more example in this video here. And this one, we're going to show that there are multiple ways to solve things, but the reason we begin using momentum and impulse is that it's actually an easier way to solve things if you have the right information than using forces and kinematics. Let's take a look at this situation. John is skating forward at 12 meters per second when he applies a 580 Newton force in the backward direction for 4 seconds. What's John's velocity after he has finished applying that force? So it looks like we have some directions going on here. I'm going to begin just by saying forward is positive and backwards is negative. Now, when solving this, we can go about this two ways. In red, I'm just going to write out the pathway that we would do this using kinematics and forces. If I wanted to find John's velocity using kinematics and forces, I would go ahead and I would use the force to find the acceleration. And then I would go take that acceleration into kinematics, and I would use my variables, VI, VF, A, D, and T. We'd find our acceleration from a force. We have the initial velocity, and we know the time, so we'd be able to find our velocity. So we'd do it in 2 different stages. And this would be a 2-stage problem, and it's very doable. We have all of the information we need, and we have all of the skills that we need. But can I do this in 1 stage? Can I do this a little easier? We definitely can. Remember, impulse has 2 ways of showing it. It's the change in momentum by the force multiplied by the time. But the change in momentum can also be determined by taking your final momentum and subtracting your initial momentum. These are the same formula. They're both talking about impulse. They're both talking about the same thing. So we can equate them. We can say my force multiplied by my time is equal to mass times final velocity minus mass times initial velocity. And if we took a gander, we can see that we know the force, we know the time, we know the mass, and we know the initial velocity. The only thing left is our unknown final velocity, the thing that we wanted to find in the first place. Hopefully you can see using the fact that impulse has 2 different formulas, we only have to do 1 step to solve this problem. And that I find to be nice and easy. I like doing things just in 1 easy step. So let's go ahead and solve this one. We have our force 580 in the backward direction. Watch those directions. So that's going to be negative 580 multiplied by the time of 4 seconds is equal to our mass of 85 kilos multiplied by the final velocity minus our mass of 85 kilos multiplied by our initial velocity of 12. Let's just calculate some of these values. And we see here that we can add 1020 to both sides to begin isolating for our variable. And divide both sides by 85 to solve for our final velocity. And we see here that our final velocity is negative 15.3 meters per second. Or in other words, John's final velocity is 15.3 meters per second in the backward direction. And so we see here that John has turned around and is now skating backwards. I hope some of these problems have showed you a little more on how to use impulse and momentum and how to keep track of a few things, such as our units, and that we can still use kinematics and forces. Have a good day.